So now, now, now we're ready. So we just want to give an acknowledgement to the rest of our team. We work on a really large team. Holly Lynn Lee, Emily Thrasher, and Rachel work with us at NC State. And then Stephanie Casey is one of the other PIs at Eastern Michigan University. And Bill Finsner has contributed to the project, especially through his development of CODAP. And thank you to the NSF. The project is funded by the NSF. So if you're familiar with our older ESTEEM materials, we have the same types of modules in our ESTEEM II materials. So these are research-based instructional modules, and they're ideally designed for people that are preparing middle and secondary, well, middle and high school, which are secondary mathematics teachers. So they support pre-service teachers in learning important skills and knowledge about teaching statistics. And in our work in ESTEEM II, we've tried to make revisions to address data science concepts and data concepts more specifically. So the way that our modules were created and designed, we have a foundations module in data science and statistics teaching. And there are two parts. So there's two modules, 1.1 and 1.2. We really consider this foundational in that you learn a lot about the important practices and processes of engaging in statistics. Just like we have mathematical practices, we try to focus on the foundations of what are statistical and data practices and how you develop those habits of mind with students so that your pre-service teachers can learn about how to develop those ideas with their future students. And so we also have developed two other modules that are also made up of two parts. One is focusing on inferential reasoning, and one is focusing on teaching statistical association. And you don't need to do those in any order. We really recommend the foundations modules first, or parts of the foundations modules first. And then there are two performance-based assessments that we've designed. One is called the screencast, performance-based assessment. And what your pre-service teachers would do if you choose to engage them is they would choose from a data set and they would screencast themselves investigating data and talking about their thinking out loud as they use CODAP to investigate data. The task design performance-based assessment is where they design a task that's intended for students to engage in. And so we've designed these to be used online, or when we developed this project, we initially thought lots of people are using, this was even before COVID, lots of people are moving to online teaching. But what we ended up realizing after we started working with other math teacher educators was a lot of people were using our materials in face-to-face settings or in hybrid settings. So Rick and I have both taught these materials. I have taught them in face-to-face and hybrid settings. And I know other colleagues of mine at NC State have taught in a online setting or also some type of hybrid. So they can be used flexibly no matter the context you're teaching in. And we do have colleagues that have used these in professional development or professional learning experiences with practicing teachers. Or as standalone experiences, even if they're not taking whole modules and putting it into their course.
And I
So,
might just
oh,
add,
sure.
Jenna,
Yeah.
that, you know, we recognize that everybody teaches statistics in different types of courses. Sometimes there are methods courses, and sometimes there are data and stats or data and prob courses for teachers. Sometimes it gets taught in technology courses. And we've seen our materials used in all of those different settings. The nice thing about the modular approach is that you can kind of choose which modules you want to implement, and by it being embedded in an LMS, it's easy to delete or modify content.
Yeah. And so these are just two examples of things you would see. We're going to actually give you the link to the modules on Canvas Commons, and you can open it up, and I'll open up some things and show you around a bit. And like Rick said, you can really put these in any type of course. I personally, when I taught with these materials, use them in a teaching with mathematics course, teaching technology with a mathematics, because our students at state, they see more data now, but they haven't always seen tons of probability stats and data. And so the focus of that course, teaching math with technology, now I got it right, um, it puts more of that content in front of them. But like Rick said, lots of people have taught them in other contexts. And we'll talk more about the way that you can kind of customize this to your own context, like Rick pointed out in a slide or two. But again, just wanting to emphasize that these really are, while your students may learn some content through these modules really are focused on helping them understand teaching and learning, although there are some things you could take out and use people have in a content course. So right now they are freely available. Well, they're always going to be freely available for the time being, but the extent to what learning management system that are available, we'll get to that part in a second. But there are more than one learning management systems which are ready for you to download. So I'm going to just open this up and give you a quick tour of some things. This is how you access it. Rick, if you don't mind,
Yeah.
would you pop this in the chat? I'm actually going to get out of the slide, and I'm going to show you where it should take you.
And if this is your first time to access our materials, you may need to register.
I'm sorry. That was the developer's website. So um, when you pop this link in, it should get you here, and you can let us know if you're having any problems. So this is what it should look like from your end when you're seeing it. I'll give you just a minute or so, like Rick said, in case you need to register, and then I will just show you some things that I want to point out before we have you engage with some of the materials.
Our focus today is going to be on the foundations module. You'll see that we have our association module and our prior original materials there too.
Yeah, so I was going to mention this later, that right now we have revised, if you're familiar with ESTEEM 1, the foundations modules, the association modules have been revised, but the inference modules are in the process being revised now. So if you want to find our old inference materials, you could go to the 2021. These were our original materials. I think you're going to want to use our updated materials, but if you really want the inference materials, you can, for now, until we get those up and going in Canvas Commons, you can use them there. And so I just want to point out a couple of things when you go into the foundations module. So in the spring, I think Rick and Stephanie are going to host a webinar focused on the association module. We might also, Holly Lynn and I might also do one on the inference when it's ready. But let's just take a look inside the foundations modules. And so I just wanted to point out these 3 pages that are under our materials overview, and I've covered some of the language that's on this page already. This is just what we already talked about in terms of it shows, it's who the modules are for. Again, like I said, the inferential reasoning modules are under revision. The only other thing I wanted to point out from this page is our Creative Commons license. So you can use these and reproduce things for your own purposes. We just ask that people site, that this was adapted from, but these are meant for you to take and adapt them so the materials best fit whatever your professional goals are or whatever your instructional goals are in your course. And so at the bottom of this page, it just gives you a overview of what's in each of the modules. So like I said earlier, this foundation modules is really the foundations of what does it mean to engage in investigating data with technology tools and developing habits of mind. With students. It also focuses on planning lessons. We focus at the very beginning on the differences between statistics and mathematics, even though we agree there are some similarities. Um, and then in the second part, we focus more heavily on this framework that we introduced in the beginning to think about how students reason, how to design tasks, how to interpret students' work. And in both modules, there's an opportunity to engage in data investigations. And Rick will share more about that later. Um, and then here's a description of those performance-based assessments. And then I also wanted to point out again that we have provided learning management system downloads for you. So we've given you this link to come get these downloads, but the other intention of building this in Canvas Commons is so you can see how we've intended the materials to look. And so if you take a look right now, you can download this for Canvas and for Moodle. The Blackboard package is coming soon. And if you work in a learning management system that's not one of these, you can use the common cartridge and you can use that. And then this is why having access to our site's helpful, because then you can like take a look to see, oh, does this really match what it's supposed to? Like Rick said earlier, when you upload this into your own learning management system, you have the option then to pick the things that work for you. So if there are specific things you want, you upload those and you don't have to take the things you don't want. And again, the association module is also ready with exception to Blackboard, but you can use the common cartridge. Right now. Canvas also, I'm not going to be an expert in this, but for us, using the Canvas package actually worked better to make the Moodle version than the common cartridge. So it feels like Canvas sometimes will pull into other learning management systems pretty well. And in the past, Moodle also did. And again, these other ones are coming soon. And so I also wanted to point out that we do have a table of contents right now. So if you're new to these materials, you can download the PDF, but you can also read it here. What it'll do is it'll help you see, and I'm going to skip down to the foundations. It'll help you more specifically see the different resources that are in each of the modules. So you get a better understanding if you're not familiar. So we try to outline the important resources, whether it's a resource that your future teachers might read, or if it's a video we think they might watch, whether there's reflection or discussion opportunities. And of course, you could adjust this for your own context. So when I was teaching online, they might do a discussion forum, but when I did it face to face, we'd have a class discussion, or I might have students write something and send it in with responses. So this will give you an idea of, again, these different multimedia resources. And I know that we are working on a facilitator's guide to give some advice about using our materials. Rick, do we know a date of when we're releasing anything yet?
We don't have a date, but we're hopeful by the end of the fall semester.
Okay, so be on the lookout for that, and we would post it here on the Canvas Commons, and that will hopefully help you with some guidance. We also have quizzes that we've used before. At some point, we might add some additional materials into our facilitator's guide. So the facilitator's guide will be developing as we move further on in the project. We'll add to that and update it. Okay, so what we want to do is give you a chance to explore the foundations module. So I'm going to turn things over to Rick to, and Rick, I'm going to stop sharing and let you start sharing, but Rick is going to take us through and he's going to have us engage in some of the resources.
Am I sharing at this point?
Yes.
Okay, so you can see that we're going to take a look at three different resources with a little more depth today. The first is a making sense of data visualizations activity. And it looks at some high school course enrollment. This is a new activity to the current version of the foundation modules. We're also going to take a look at investigating roller coasters, and PSTs in this activity learn how to launch a task and then investigate a data set of 33 older roller coasters in the US and supporting statistical discourse with the roller coaster task. If you've used the 5 practices model, you'll definitely see some connections between this activity. I think it's a nice way that we've embedded um, other frameworks from math education into our materials, and we'll see how the teacher selects sequences and connects students' thinking in that video. So I'm going to take you, to the module itself. So if we go into the ESTEEM Foundation, the first one we're going to take a look at is called Making Sense of Data Visualizations. One of the things that we've done in the current iteration of the module is to have a heavier emphasis on data science. We know that a lot of states and school districts are incorporating data science either as a course or within courses. And so one of the frameworks that our students get introduced to is the making sense of data visualizations framework. And it connects to the data investigation process. I'm going to point that out real quickly. And
Yeah, I forgot to talk about that. I was gonna come back to it, but I think
that's
this is,
okay.
yeah, if you can talk about it, Rick, but this is one of the biggest changes we made, like Rick said, in response to trying to focus more heavily on data science and also serve statistics.
So yeah, incorporating a different process. In the past, we used sort of the 4-step process, the cycle of um, you know, investigating data. And so this data investigation process, I think, is much more in align with how we think about data science practices and processes, right? And so it emphasizes some different things than the 4-part cycle did before. So the data investigation process involves framing a problem, considering and gathering data, processing data. Those are very different ways to think about collecting data, right? I mean, a lot of times the data that data scientists encounter, they're not necessarily collecting their own data, but they're thinking about how is the data gathered, and then that idea of processing, cleaning messy data, thinking about how we manage or structure the data. That's part of the process. Exploring and visualizing data, consider models, and communicate and propose actions. And so this entire process is something that we've embedded throughout the materials, and you can see we've got a video here as well where they get introduced even further to to that process. Is there anything else you want to say,
One of
Gina?
the things I just want to point out is, so two things. When we developed this work, Holly Lynn and Emily and I really thought about this data investigation process for a different project. We we looked at the literature, and there wasn't a lot of literature about data science. So we started with our foundations of what we've been doing in statistics education, and then we went and we looked at what professionals do. So there was an ethnographic study that was done, and then we combed like blogs, we talked to data scientists, we looked at the literature we could find. So this framework is going to feel familiar to you if you've worked with statistical frameworks, whether it's a 4 or 5 phase cycle, the statistical problem solving process, right, and gaze. But we really have tried to highlight, not that we didn't do these things in with statistics, but we really tried to highlight those data science practices and processes. And then the other thing I just wanted to point out was that the explore and visualize data and the consider models, some people call that the analysis phase. And we were just trying to acknowledge that before you formally are finding models, you oftentimes are doing this visualization with data, and a lot of tools now support that visualization, which is leading us to the first resource that Rick was wanting us to engage with. We're just really trying to recognize the importance of visualization and using tools that allow you to visualize data.
So in 1.1G, students are introduced to this data visualization framework, which involves making sense of data. And you can see that it connects specifically. You see those puzzle pieces of the data investigation process throughout. We try to use that visual identity with the depth of data investigation process. And Jima, you want to share about the development of the framework?
Yeah, so Holly, Lynn, and Emily in our InStep project and the rest of our team really wanted to highlight the importance of data visualizations. And so there's a framework that we've been using to help people, whether you're a future teacher, a practicing teacher, understand like how to make sense of data visualizations. So one of the most important aspects that you probably already know is that it's really important to help prepare teachers to help students think about the context of data, right? Otherwise, we're just talking about mathematics. So we really think it's important that teachers understand strategies for doing this. And there's also this other piece, right, about like being able to look at whether it's a dynamic visualization or a static visualization, being able to like makes sense by understanding and reading that visualization. So the things that around reading the visualization are probably things you're already familiar with, like being able to say something about the scale, like does the color gradient matter? And then I think the two pieces that might be newer to data science are this idea of personalizing the data, helping students understand maybe they're represented in the data who might not be represented in the data, right? Do they have experiences or things that might help them relate to that data? Are there perspectives that they have that might engage them with the data? And then finally, it's really about this idea of, okay, so what? So let's communicate something now that whether it's the data investigation process or we're interpreting and evaluating a visualization, it's this idea that we've made sense of the data, but so what? We need to communicate something back or propose some kind of action. And then we have a link that will link you to questions that fall in each of these big pieces of the framework, which you can provide to your prospective teachers that helps them think of the types of questions they should ask students to help students either personalize the data or make sense of the context. So that's just a little history of the development of that framework.
So when I've used this with my pre-service teachers, I introduce them to this framework first, and then we use it to investigate a data visualization. So this is the data visualization. I'm going to click on it so that we can see a larger version of it here. This is the data visualization we use. This is about enrollment patterns for high school students in math and science courses. You can see math is in the first sort of 5 columns here. Science is in the next 3. And so I often begin this conversation just by asking students to notice and wonder. And so I'm going to ask all of you, what do you notice about this graph? And if you can, add something to the chat if you would. Add a message about what you notice or what you wonder about this. And I'm going to pause for a minute to allow you to take a look at the data set and add a comment. So yeah, Rob knows as time progresses, students take fewer math and science courses. We have smaller percentages for higher courses here. Biology, wonder if it could be the subject required for most ninth graders. Wonder what types of schools do not offer Algebra 1 in high school. That's an interesting question. I wonder how maybe integrated math or something. I don't know if that's reflected here. So yeah, some of you are noticing colors. So the blue color is all high schools, and the green color is high schools with high Black or Latino student enrollments. And Amelia noticed that those schools tended to have a smaller percentage in almost all the categories. Yeah. One of the things that I always like to point out, and I hope that students are noticing, are the source, right? So, this data comes from the Office of Civil Rights in the US Department of Ed. Was collected between 2015 and 16. So I always feel like understanding where your data comes from is part of that process, right? Of considering the data. We have several specific questions that can align. Some of them we've already addressed here. What do you notice in the graph? What do you wonder? Like I said, those are things that we want everybody to consider. We've addressed some of the reading of the visualization. So you'll notice these questions align with the same framework that we had above. So if you continue to think about what do the two colors represent, a lot of these come up in the noticing type questions, right? How do you think the US Department measured whether a course was offered at a school? Thinking about the percentages, thinking about if there are trends. I'm seeing some more chat here. So I noticed that the percentages were between blue and green were similar. Larger differences for calculus and physics. Denise said, I'm notice that at first I was reading it as a percent enrolled, but the title says percent offering, right? Great point. So yeah, these describe percentages of high schools, right? Even noticing the title sometimes sometimes it helps for students to think about what are we actually describing here. Good point. Thinking about those what do those percentages mean? I'll be honest, like when I did this with my class, a lot of these questions come up just in the noticing and wondering. And so I sort of use these questions as sort of my crutch if I needed some help or needed to support my students in a different way or point out something that they didn't notice. We designed it for an online audience. So if you're using this in online, the questions are right there. You could have students respond to these questions if you want or if you choose to, right? Like if you want to make this more of an assignment, you can. We didn't really build it in as something that we thought that students needed to turn in, but you certainly can modify it like that if you want. We also take a look then at enrollments between males and females. And so I'll give you a minute. This is displayed a little bit differently, right? It's different from the bar graph that we had before. But I'll give you a minute or two to notice or wonder here about differences. And the first line is high school enrollment. So we've got 51% of our high school students are male and 49% are female. What do you notice or wonder about this data set? So we notice there's not much of a gender gap. Algebra 1 is required for all. I wonder why the percentage of female is so much lower than the enrollment. Yeah, I don't know. This says in high school. I also wondered, like, are they counting students that might enroll in Algebra 1 in middle school? I don't know about that. Seems like something to ponder, though, right? Those are the kinds of questions we want students to think about with the the habit of mind of being skeptical about the data, right? Wonder about a larger gap in physics. Pretty big gap, maybe between male and female there. Wonder what the whole is. Good point. So this is only showing male and female students. So, how would we include non-binary students? Great question. I also wondered, like, over time, it seems like as the classes got more difficult, we saw fewer males, but then in calculus, it seemed to reverse, right? That seemed a little surprising to me. I wondered why that happened. The last graph, and I think this is the one that I probably spent the most time on with my class and noticing and wondering. This takes a look at each of those same courses. There is one difference that they've broken up Algebra 1 in grades 9, 10 and versus 11, 12. So these describe the percentage of students enrolled in high school math and science courses by race. And you can see the races are shown in the colors down at the bottom. I'll give you a minute to think about what you notice and wonder here. It's a lot to take in with these segmented bar graphs. Young noticed there are more differences in math than science. I agree. Like if you look across the sciences, they tend to be pretty similar in terms of their course taking patterns. We see a little bit more differences in math, especially as you move to calculus is very different, and lots of differences in what grades they're taking algebra 1, right? See a big difference between the distribution of individuals who are taking algebra 1 in grades 9 and 10 versus those in 11 and 12. So one of the reasons we chose this context is, we wanted to choose context that we felt like high school, prospective high school, secondary teachers might have an interest in. And so this is certainly one that makes them question about why there might be differences when we look at gender and race, um, and certainly one that impacts their future careers as teachers. So I'm going to go back to the module here. You can see, like before, we have questions about the segmented bar graph that is split up using the framework. And then at the bottom, you can also choose to look more at the site that has different visualizations. And so students have the ability to kind of interrogate more data from the Office of Civil Rights. So this is one of the new activities to this module that we didn't have prior to the updates. I think it's a great addition to have them think about this process of how do we analyze data visualizations and how do we help students to unpack data visualizations and to also engage in some of that work themselves. I'm going to stop for just a minute and reshare because I think I'm need to slide. Okay. Also in the first module, so I mentioned before, I think Gima mentioned before that we have two modules within this foundation set. The first module is really focused on what statistics is. And so as part of that, they get an introduction to CODAP. And our first workshop that we did, the webinar that we provided last month that Gima led as well, introduced folks to CODAP. And if you have not used CODAP before, I encourage you to check it out. That's not the intent of this lesson, but we do have activities here to help our pre-service teachers learn about how to use CODAP and a couple of getting started activities that will help to teach them about CODAP. CODAP leads into our next data engagement. And so this involves investigating roller coasters in the US. The roller coaster activity really starts with watching a video. And in the video, I'm not going to show the whole video, but I'm just going to show a snippet of it here. This is actually, and I'm going to talk over it so we may not actually hear Holly Lynn as much here. If you know Holly Lynn, she's featured as the teacher in this video. She's leading a group of middle school students in a data investigation, and they getting introduced. One of the nice features about this is that it emphasizes how to launch a statistical investigation. And so Holly Lynn does several key activities, key moves, teaching moves. One of them that she does is show a video, and she brings up a YouTube clip of a video and shows a video of a roller coaster. The conversation that kids have about that is that they start to talk about many of the variables that they'll end up investigating in the data activity, in the investigation. So it's really interesting because as they watch the video, natural things start to talk, come into the conversation. They talk about, what an inversion is. And Holly Lynn's able to sort of say, well, an inversion means that it's 90 degrees. There's a personal connection made. So a lot of the kids throughout the launch talked about aspects of either their personal experience of riding roller coasters, or things they had heard about riding other roller coasters. So when I teach with this video, we often debrief like or what did we see in the video that created a strong launch that really launched the data investigation. At the end of the data investigation, and this is a key point as well, Holly Lynn poses a question to the students. And so she lets students understand what the question that they'll be investigating in the data set is. This builds on some of the work that Stephanie Casey and I have done with Heather Barker and others to try to investigate what makes strong statistical launches. And we've been trying to think about this across the past few years. After they see the launch, so the launch kind of serves two purposes. On the one hand, we talk pedagogically with our students about how to launch a data investigation. But on the other hand, it also leads them into their own investigation. And so we have a data investigation involving um, a small data set. And if I open up the data investigation here, you can see we provide them both in PDFs and Word documents. I find that if you want to modify, you can. You don't have to share both of them. I feel like sometimes it's easier to share a PDF so we know they're not making any changes. But a lot of my students like to actually have the Word file so they can write their answers and type them directly into the document. So I typically share the Word file with my students. Um, this data set is about 31 older roller coasters in the US. And so they investigate relationships between max height and track length. So you can take a look at how CODAP here can investigate this data and how students can take a look at those relationships. A lot of the things that they look at are differences between wood and steel coasters. So they might compare the max height. Didn't go where I wanted it to. There we go. I know when I've used this activity, one of the things that my students will often do, even at the college level, is that they may use these dot plots to talk about differences, but they may not actually follow through and actually look at things like measures of center and spread that will back up what they're saying. So they may say things like, it seems like the average wooden coaster is higher. I mean, I encourage them, well, if you think that, go ahead and add the mean, because in this case, it's actually the steel coaster that was higher, right? So I try to encourage them to back up what they're saying. Certainly one of the big differences is spread here rather than the actual average. All right, the last thing I would like to share today, and we are gonna watch a video. I showed you a little brief snippet of Holly Lynn there. As we progress on into the second part of the unit, the second module focuses on supporting students' data investigations. So kind of moves away from what is stats and how much should we teach it, to thinking about students and how we can support them. There's a number of questions in 1.2a, 1.2c. I feel like students get a good sense of what they need to be thinking about as they plan for instruction and as they think about supporting students. I'm going to focus on 1.2g here. No, 1.2h. 1.2g is examining students' work. It takes that same lesson that we just saw the launch for, and in 1.2g, we examine how students engaged with that roller coaster task. And so I'll click on here so you can see there's a video here of those 6th grade and 7th grade students exploring attributes. We get to see how they engaged in that activity. I'll let you explore that one on your own because I want to focus on 1.2h. So 1.2h is a great video. We introduce students to the 5 practices. So, you know, in my class that I teach, my colleague teaches another course that they have before where they actually get introduced to the 5 practices. And then this is a nice connection because we're able to build on that and think about that for statistics. So there's a reading here. The reading could be optional. If students in your class have already learned about the 5 practices, this may not be necessary, but it gives a nice sense of those practices that Peg Smith and her colleagues talk about: anticipating, monitoring, selecting, sequencing, and connecting. And we see that in the video that follows. So I'm going to turn this one. Hopefully you can hear this. I'm going to go ahead and play it, and you let me know if you're not able to hear this. Shima, can you help me here?
Find out about these posters.
I can hear.
You
started.
I'm going to forward on to about 3 minutes in.
So they created 2 graphs. All right, tell us about your graphs and what you found out.
Have the top row dragster in Cedar Point, that's in Ohio, has the highest drop and the highest speed.
Oh, okay. So you created these 2 graphs and then you looked at the one that was, did you click, when you were clicking on the dot, did you click on the dot in the drop or did you click on it in the top speed?
The top speed.
In the top speed. So you clicked out in the top speed. So, you know, find the one that goes the fastest. And then you notice that it also had the biggest drop. All right. Do you think that that's true on the other end? The one that's the smallest, that has the lowest speed, also has the lowest drop? No? All right. Did you test it out? Did you look?
Yeah,
but no?
not tempted.
Now you're tempted? Well, go ahead. Click on one of those low speeds and let's see where it is.
Yes,
Yeah, it's down there. And so if we don't have a lot of speed, we probably, in this case here, we didn't drop very far. Okay.
And so what we did was we got the top speed. So we do the top speed and then the drop. Then we put a drop in the middle of the beat. And then that's what ours looked like. The darkest green meant the drop. Lighter the green was the lowest the drop.
All right, all right. So, so they used that color like you guys were doing, but they had top speed on the x-axis. And so this graph kind of tells us some of the same information that the 2 graphs made, but it's all in one graph. All right, and we were using color to kind of show the intensity of drop. Nice, thank you.
It also did something on that site, but for some reason, the 2 at the top, it didn't show. So we, thought that they didn't probably weren't running anymore, so that's why what it showed. We got figured it should.
Oh, I wonder if we just needed to, so with the max height, did you put it like where you have top speed on the x-axis? Is that what you mean?
Yeah.
Go ahead and drag max height on there.
Oh, and I mean, it was just having some fun, so we were just looking at what was on North Carolina.
Uh-huh.
So, and I think it was, Fury, yeah, 35 or something like that, and something else.
Intimidator. Yeah.
And Fury 35 was like one of the best ones in max height and top speed and stuff.
Yeah, that coaster looks crazy. So while they're doing this, from some of the things that you've learned so far, we've had 157 roller coasters from the US. Do you think those are all the roller coasters in the US?
No.
No, there's actually a lot more. Not even, I'm not even sure that how many there are, but I think it's over 1,000. Okay. You didn't even see what? You didn't even see his favorite roller coaster. So we don't have them all. One sample. Okay. And we're learning some things. And one of the things we just looked at was top speed and drop. And we were looking, it was fun to kind of find out that special coaster that was like had the top speed, the highest speed in our data set, and the largest drop. But we don't know if that is the largest with top speed and drop. Right? All right, yeah. So and again, they were looking at drop and top speed, but they arranged the graph a little bit differently. All right, can you tell us a little bit about your graph?
Well, we we were just playing around and we were comparing drop and top speed, and then I added in type. And this is how we came up with this graph.
Okay.
I'm going to pause it here because I think you've seen enough for me to make the point that I want to make. And so, as we thought about across all of these, you saw three different groups of students that presented at the end of the lesson. And I feel like there's a natural way to think about the progression of those three visualizations that were created. So if you notice the first two girls that were presenting, they created two different dot plots, and we're looking at two variables on two different graphs. Holly Lynn prompted them there to actually investigate, well, if one was low, was the other one low, right? So that they could kind of look for differences between the graphs because the representations are linked, right? The second group, the two boys you saw there in the next segment, they created a single graph, but they overlaid colors. So they used color as a way to look at a second variable. The last group of students, they created a scatter plot initially. And so they were looking at two variables with the scatter plot, and then they overlaid color on top of that to add yet a third variable. So when I talk with my students about, why do you think she chose these students to present? Why do you think the teacher also selected them? That's one of the questions I like to highlight. So in an online setting, we have students often write a paper after watching this video where there's several questions they have to address. Like Gina said earlier, if you're teaching this in an online or in an in-person setting, face-to-face class, these are questions you may just want to have as a class. And so a lot of times that sequencing and selecting is something that I always like to bring up as a important topic to bring up, and it's mentioned here in number 5. Also thinking about connecting. So how can you connect those representations across from one another? I also want to point out all the videos that we created, we have transcripts for. So I know sometimes the students' voices are a little difficult to hear. The transcripts will hopefully allow our pre-service teachers, if there's something they can't understand, they can hopefully look back and read through it in the transcript. All right, we have about 5 minutes left, and so I think we've shared most of what we wanted to share today. I want to give some time for any questions you might have. And so I'll pause here. If you want to add any questions to the chat, feel free. As you're typing your questions, I'll just say that there's lots of ways you can continue to connect with us in the ESTEEM project. We have a hub that we keep maintained. You can learn more from our hub, that link down there in the bottom right corner, or you can, um, I guess in the upper right corner, we can find the QR code there. We have a Slack channel, a newsletter. You're welcome to stay abreast of everything we're doing. Our next webinar is going to be focused on using InStep to support math teachers, and it will be on Thursday, November 20th. We hope that however you got to this webinar, you probably have the same link to get to that webinar, but if not, feel free to let us know and we can share. And so with that, I'll pause for any questions. We're happy to talk about the foundation module or any of the work that we're doing. Well, thanks for coming, everyone. We'll be happy to stay on for a few minutes if you have other questions.